In this video, I'll be talking about production of X-rays and then its interaction with matter. Okay, the ways of how the X-rays are produced. The X-rays, the mainly two methods which we study normally are Bremsstrahlung radiation and characteristic radiation, which are formed. The X-rays are formed. First, in the Bremsstrahlung radiation, the incident photon, as we can see in the first picture, the picture A, the incident photon directly hits the nucleus, or as in the second picture, it just nearly misses the nucleus, okay, but it is in the vicinity of nucleus itself. This leads to the formation of Bremsstrahlung photon, which has a maximal energy. If the incident photon is directly hitting the nucleus, the entire energy is converted into a photon called as Bremsstrahlung photon, and this is Bremsstrahlung radiation. Similarly, if it nearly misses also, the Bremsstrahlung photon is formed, which has a very high energy but lower than the example in first one, like lower than the direct hit, but still the energy of photon will be quite high. Okay, so there are the first method is Bremsstrahlung radiation, in which the incident photon is a direct hit to the nucleus or a near miss to the nucleus, where Bremsstrahlung photon is formed. Second is the production of characteristic radiation, in which the incident photon displaces an electron. Okay, the incident photon will hit an electron of the inner shell. The electron is removed, called as recoil electron, and a valency is formed. The valency, that is a vacancy, is formed because the ion has become ionized. Okay, the element has become ionized now, it is an ion. So there is a vacancy in the inner shell. So, a electron from the outer shell will move to the inner shell. This electron will release some energy. This energy is the difference of the outer shell and the inner shell. Outer shell has more energy, inner shell has lesser energy. So, the energy in the electron releases the energy which is balance. Okay, the subtraction of the energy of these two orbits is released, which forms the characteristic photon. This is characteristic radiation. Okay, so this is how the two methods, how the X-rays are produced. This is occurring in the X-ray tube head. Okay, so the metal which we are talking about, the atom which we are talking about, is mostly a tungsten atom. Okay. So next we have interaction of X-rays with matter. Now the X-rays are formed and they are interacting with matter. Here in our field, pertaining to our field, the matter is skin or the other tissues of the human body. Okay, so here matter is human body. So when X-rays come in contact with our body, there are three most common methods how it interacts, that is coherent scattering, Compton scattering, and photoelectric absorption. First, in coherent scattering, there is the incident photon has very low energy. Okay, that is the energy is less than, sorry, the coherent scattering, the incident photon has very low energy, which is less than 10 electron volt. It strikes an atom, but the energy is not enough to cause instability of the atom. So the atom only gets momentarily excited, but it quickly returns to stability. Okay, and a scattered photon is released at another angle. We can just say that it means incident photon strikes an atom, but it couldn't produce an effect on atom and comes out as scattered from another point. Okay, so incident photon with low energy and a scattered photon is formed. This is coherent scattering. Next is Compton scattering. Again, the photon has less energy, but it forms a scatter photon and a recoil electron also. Okay, so obviously if some of the energy is used by recoil electron, the energy of scatter photon will be less than incident photon. Okay, in coherent scattering, the energy of scatter photon was equal to the incident photon, because that is the only thing formed. In Compton scattering, recoil electron is also formed, so the scatter photon will have lesser energy than incident photon. Okay, some of the energy will be lost to the recoil electron. Okay, and also Compton scattering is the major source of secondary radiation. Last is the photoelectric absorption. Here the incident photon gives its energy to an inner electron. Okay, as seen in the first picture, the energy of photon removes the electron, so now atom becomes ionized. It is same as the characteristic radiation, the only difference is it is occurring in matter. Okay, and the vacancy is formed in the inner orbit. The electron from outer orbit will fill the vacancy. This will produce characteristic photon and has the energy equal to the difference of two orbits. This is the same as characteristic radiation, but here actually absorption is occurring in the matter in the human body, so it is called as photoelectric absorption.